Good afternoon, everybody. This is Steve Wilson from the State Water Survey. Thanks for joining us today, our webinar on Water Well Chemistry 101. A few things to mention at the beginning. This is part of the private well class, which is a partnership between the Rural Community Assistance Partnership, RCAP, and the State Water Survey at the University of Illinois. This isn't the class itself. The private well class is a 10-lesson class. I'll describe a little more about that later. These webinars, though, like today, are meant to support, one, answering your questions, and two, provide additional information that'll help you as a well owner, or if you serve and work with well owners, to give you more information to build up your expertise, so to speak. So this is all funded by the US EPA through a technical assistance and training grant program they have. And thanks for joining us. Okay. So I already mentioned this part of a national program. It follows a private well class. I do want to mention this is being recorded. We record all of our webinars. I think we're up to a little over 90 that we've done, or maybe a few more. And it's available both on our YouTube channel and on our privatewellclass.org page. If you look under webinars, there's a past webinars tab. This will be up online probably by the end of the week or early next week. And you all were given an opportunity to ask questions when you registered. We had over close to 100 questions, I believe, which obviously we can't answer all of those, but we will answer a number of them between Evan and I. And also, if you have a question that comes up during the presentation today, put it in the chat box or your question box on your GoToWebinar screen. Katie is monitoring that, and we'll make a list of those questions. We share a Google Doc, and I'll pull that up at the end. And we're willing to stay and answer questions for as long as you're willing to stay and ask. So I also want to mention NEHA here because we're a partner with NEHA in this program. We're a CEU provider as well as for Illinois LEHP credit. Okay, so speaking of that, if you're looking for continuing education credit, if you're a NEHA person, note that you can't get this is kind of irrelevant today because we've never offered this particular webinar before. We have Evan Ray from our lab, and I'll introduce him in a second. But typically, just to be aware, you can't take the same class more than once. And many of our webinars we offer 2 or 3 times a year. And for CE credit, you'll only be able to take that once during your 2-year accreditation cycle. But for today, we can provide a certificate of attendance, a copy of the slide deck, and work with you to complete your NEHA forms. There are handouts available on the GoToWebinar handout button. And yeah, I think that's those issues. If you do want a certificate or the slide deck or whatever, email us at info@privatewellclass.org. And we're a small group, so give us some time. The last month, I think we had over 200 requests for either the slide deck or certificate or both. And so that takes a little bit of time for us. And so if you don't hear from us tomorrow or even until next Monday, please be patient. Okay, so a little bit about RCAP, our partner in this program. Really, this program is split up among a number of partners, but we provide the online class and do a lot of outreach as well as try to answer folks' questions. We have a 1-800 number that people can call us, and we get calls a lot. RCAP does more of the boots on the ground type of work. So RCAP is a partnership made up of 6 nonprofits. You can see them listed here in the areas they cover. We're in Illinois. So we're part of Great Lakes RCAP, or the Great Lakes Community Action Partnership, and they have 4 or 5 staff in Illinois, not that are all working on private wells, but they do a lot of work with small and rural water and wastewater systems as well, and even in economic development in rural areas. But note which state you're in and which of these organizations would serve you. There's a couple things that'll come up today where you may want to reach out to them. You can always reach out to us and we can make contact for you. We do that a lot when someone calls and has questions. They're able to provide, like, I think I'm going to mention this assessment tool. We developed this tool that allows you to do a one-on-one assessment of a well and the area around it and look for vulnerabilities. Is it got a proper cap? Is it in a floodplain? Are they storing things nearby? All those things that might make your well vulnerable to contamination. And it's free, and it's a great service. They've done over 3,000 of those. And so, if you're interested in that, you can let us know. We can get you in contact with the person in the right state for you. So Katie and I are both from the State Water Survey. Did I leave out the slide with, oh no, I did, that's coming up. In Illinois, we have a State Water Survey that's a sister agency to our State Geological Survey and our State Natural History Survey, which every other state has. I believe there's one other state that has a State Water Survey, but we were formed in 1895 because of the cholera and typhoid outbreaks. So we've got a long history of working in public health and helping well owners, as well as we have atmospheric science and surface water groups and chemistry groups as well. But we've learned a lot about water and done a lot of seminal work on treatment and other things through the years. I show this fairly frequently. This is from our files for Pana, Illinois. In 1916, they had a typhoid outbreak, and the Water Survey investigated why that happened. The red dots here are all the homes where they had a case, and it turned out, you can see the arrows there to the Pana Ice Cream Company. The town had built a new water system that had treatment in 1912, but they weren't using it because the mayor said it cost too much to run. Only half the town was sewered, and so between those two things, it was assumed one of those had caused a typhoid outbreak, but it turned out it was the Pana Ice Cream Company sold milk, and they had one large tank or vat, if you will, that everyone used a bucket to scoop their milk out of, and it had typhoid. And so it caused these 30-some cases of typhoid in 1916. And I mean, it's just a good example of the work we've done and how long we've been around. We house the state's well logs in Illinois. We have records of over 500,000 well logs, and we've just got a lot of experience, and I guess that's my point. This is another picture from New Athens, Illinois, down by St. Louis. This was in 1915, I believe, a young man helping one of the Water Survey chemists test the water in their community water supply. Okay, so I'm Steve Wilson. I'm a groundwater hydrologist at the State Water Survey and kind of the host today. We have a special guest, I guess, Evan Ray, who is the director of our Health and Environmental Applications Lab, HEAL, which is our chemistry lab here that does private well testing as well as other kinds of testing in support of research projects and other work that we do. And Evan's going to talk, he's the chemist, and so he's going to provide most of the content today. And then Katie Buckley, who's with our program, the private well class program, is our water resources outreach specialist. And she's going to field your questions. She'll work with you on your CE information and basically runs all the background for these so that it makes the rest of us look good. So thank you both for being here. Before we get started, we're going to ask a poll question. It's one of the ways we track whether you're actually paying attention. So especially if you want CEs, you should probably answer this. But it's good information for us to have. And yeah, Katie, go ahead and start that.
Sure, yeah, absolutely. So today we're asking you, what role best describes you as a participant on our webinar today? And like Steve mentioned, this is just for our own metrics and so that I can successfully issue you any certificate of attendance if that's what you're looking for. So please take a moment and go ahead and respond to our poll question. We'll give it about a minute or less. We have about 71% of you voted. All right. Give it about 10 more seconds. So get your last minute votes in. Okay. I am going to go ahead and close the poll, and then I will share the results. Poll is closed, and here I'm sharing the results. It looks like the majority of you, about half, are representing a regulatory agency, and we do realize many of you may fit into more than one of these categories, but just for our metrics, like I mentioned, whatever best describes you. So
All right, thanks.
I'm going to go ahead and hide the poll, and Steve, you can take it from there.
All right. So a couple things before I hand this off to Evan, try to make this clear, especially for the well owners who are here today. Private wells aren't regulated. And so it's really up to you as the owner and user to be sure your water is safe to drink and that the system's maintained. The best way to look at that is that you are the water operator for a very small water system. And so the other thing is that, and I know we had a couple questions here. We're like, well, I've never tested, but my water's fine. We hear that a lot, but a lot of things can be colorless, odorless, and have no taste, like arsenic, and it's naturally occurring. The only way to know if that's in your well water, if it's in the groundwater, is to test. And so testing is the big theme for what our program stands for, mainly because without testing, you don't know what's really in your well, and it very well could be nothing. A lot of well water is perfectly safe to drink as is, but unless you test, you really don't know. So I grew up on an old dug well. I say that a lot on these webinars. It was only 14 foot deep, and it was basically always contaminated. Now, though, I live in town. I'm on a city water supply, and the $40 or $50 a month I pay for my share spread out over the 150,000 residents goes for sampling, maintenance, infrastructure, so that when I turn on my tap, I always have water pressure and I know it's always safe to drink. A licensed water operator and a whole team of folks who ensure that the water coming to my home has chlorine residual so that it's no bacteria issues and all those things. That's your responsibility if you're on a well, period. And no one's going to do that for you. And so it's really something to take seriously, especially people who, the well I grew up on, my body got used to it, so I wasn't sick all the time. But when other people came over, or actually when I left for college and was gone for 3 or 4 months, I could no longer drink our well water without getting sick. And that's because the bacteria, I'd lost that in my stomach, and I'd been drinking community water supply water for months, and it changed all of that for me. And so it's really a big deal whether it makes you sick or not. If you're not sure, you should test. And that's kind of the bottom line. I'd be glad to answer more questions about that at the end. Okay, so what our program really gets to are these 4 or 5 things. You should have your well log. If you don't have a well log, try to find a surrogate information or find out who your driller is, all those things. But you should know the depth of your well, the pump setting, if it has a screen or not. Is it a sand and gravel well or is it a bedrock well? How deep it is. Yeah. If it might not have a submersible pump, it may have a pump at the surface. That's also telling. Those things help you understand your unique situation, which every well situation is different. And as far as knowing whether there's naturally occurring contaminants or water quality issues, ask your local health department. They will know, or your state health department or your state resource agency. If you Google water quality in my state, you're going to get either the USGS, your State Geological Survey, DNR, DEQ. There's a lot of different, the folks that actually study that and do research related to that, or maybe it's at your university, but someone knows, like we know where there's arsenic in the state of Illinois and where there's other issues. We know where there's flowing wells in Illinois, and there's only a few areas where that happens. All those sorts of things, there are folks in your state that understand and know those things because they've studied your water resources. And by going through the class that we have, take the 10 lessons, don't just do the webinars, which is all free. It'll help you learn to ask better questions and the right questions and understand who your local sources of information actually are. In different parts of the country, it's different. In the East, you have health districts. Massachusetts has 300 and some odd local health districts. They each are centered on a town. In Illinois, which is 5 times the size of Massachusetts, we only have 86 county health departments. So it really matters where you're at and understanding who those people are. And lastly, again, sample your well. And that's, we can't say that enough. And I know there's several questions about that, and we answer that in the questions at the end. And so with that, this is, I'm going to pop this up, but Katie's going to switch us over to Evan, and he'll have control. And so Evan, welcome to our webinar today.
All right, thanks, Steve. And all right, are we seeing the correct slideshow? Oh, well,
I'm actually seeing your
You're on the
presenters.
first slide. You need to go to slide 12.
yeah,
And
okay,
this is the old version. Yeah, there you go.
okay.
Actually, we're seeing the side that has both the next slide on it.
It got flipped. Let me
I can just do it if you'd like.
yeah, maybe it would just be easier. In the sake of time, why don't you go ahead and do it so it's on the right thing without me having to mess around with my
Okay,
monitor.
I
So
will
can
give
you-
it back to Steve.
Yeah, thanks. All right. Sorry about that. All right, here we go.
All right, thanks, Steve. Yeah, I'll just say next, I guess. So yeah, my name's Evan Ray. I work here at the Water Survey, and my background is in environmental science, and I've worked at drinking water labs in upstate New York. I am from upstate New York, and I grew up on a well, so I feel like I have a little bit of personal involvement in this topic. So my goal today is to provide some basic information about water quality as it relates to private wells, and hopefully give everyone a little bit more information about the chemistry related to drinking water quality, so that, like Steve said, you can ask better questions and get the information you really need. So a lot of this is sort of redundant with what Steve said, but one thing to mention is that, and Steve would know better too, when I look up how often should I test my well, I Googled that preparing for this, and there's lots of different suggestions. Should you test it once a year, every other year, this, that, and the other thing? And the answer to that seems to be that it depends. It depends on a lot of different factors. And that's going to be a theme throughout my talk, is that what you test for, how frequently you test, it is going to depend on a variety of factors. It's going to depend on the aquifer type, the geology, the construction of the well, potentially the age of the system, or what type of plumbing you have. So there's a lot of questions that go into determining the answer to what do I test for, which is a question we get a lot here at the lab. Next slide.
Okay, why didn't that go forward?
So in Illinois, I'm using Illinois as an example, but we have almost 2 million people using over 750,000 private wells for drinking water. Countrywide, it's about 10% of Americans use private wells for drinking water. So there's a lot of people that rely on private wells. And in my experience, most people do not test. Our lab, we're a small lab here at the Water Survey, but last year I counted, I think it was 89 private well customers requested a test from us. So there's a few reasons why, in my experience, people do not test their water. The number one being cost. If you wanted to get tested, a test for everything we can do here at the lab, it would cost upwards of $200, about $220. So cost is definitely a factor. The other thing is people really are unsure of what to request, or if they want to get it requested, they're unsure what the results mean. And some people are even unaware of the need to get their water tested. Like I said, I grew up on a well. We never got it tested. It wasn't even a question. We were just like, oh, well, it kind of tastes bad, but not a big deal. But in hindsight, knowing what I know now, we really should have got it tested. And the last thing that I actually experienced at last year's state fair, I was working the booth with Steve, and we were talking to a person, and we said, well, if you have a private well, he said yes, and we said, well, have you ever gotten it tested? He said, no, I don't want to know what's in it. And that actually inspired me to do the talk today, because I really want to spread the message of what types of constituents or chemicals can be in your well, and why you should want to know, why you should care about that. Something that Steve and I are working on, a separate project that complicates the issue of why people don't test, is equality. I'm not going to get into that today, but it is a question: does everyone actually have the same resources and information available and are we reaching them with these messages? Next slide. I want to do a quick primer on the I'm not going to talk too much, don't worry, about the periodic table of elements, but I did want to show briefly to kind of provide a visual what we test for or what we regulate in drinking water. So if you're talking about municipal water, they do have what's called primary drinking water regulations that's set by the United States Environmental Protection Agency. So there's a federal program for the safe drinking water. It's called the Safe Drinking Water Act. And in red, I've circled the primary constituents that have regulatory values. And so this means that there's a certain level above which the water should not exceed that value for safety, for consumption. We also have secondary drinking water regulations. And secondary, they're more guidelines than regulations. They're not enforceable, but they are created to give you guidelines about aesthetic value of the water, how maybe above that value the water might taste foul, it might cause scaling or deposits, or it might be discolored or discolor your fixtures and clothes and things like that. So I'm not going to talk about absolutely everything on the table, but one thing I'll just draw attention to in the center with the where it provides the example for chlorine. It gives you the chemical symbol and it gives you the name, and in the top left corner it usually will give it an atomic number like that 17, and so that makes it easy to find in the table the element. So if you're ever curious and you're Googling and you're trying to find chlorine, you can count up to 17 by starting with hydrogen at 1 and working your way left to right until you get to number 17, which would be chlorine. But we don't need to go too much into the periodic table. There's lots of trends and interesting things about it, but we'll go ahead and skip that and get on to the next slide. So basic terminology in chemistry is very different than the terminology we might use in our regular life. So I wanted to provide some real basic overview of some of the things we'll talk about today to hopefully make this demystified for everybody. So when we're talking today, I'll talk about ions in the water. All that means is an atom or a group of atoms that carries a positive or negative charge. And they lose or gain charge based on the number of electrons that they gain or lose. So that's just the definition from the dictionary. When an ion loses electrons, an electron being a negative charge, that makes the ion positive, and we call that a cation. And on the reverse side, when an ion gains an electron, we call that an anion because it has a negative charge, similar to anions or anodes and cathodes in a battery. So the example, a real easy everyday example would be sodium chloride or your table salts. You see the grains of salt in the jar, and you sprinkle it in some water and it dissolves. It dissolves into a sodium ion and a chloride ion. And so sodium having the positive charge would be the cation, chloride having the negative charge would be the anion. Similar example with sulfate that we do sometimes see in groundwater, SO4 with a -2 charge. So that number in the top right corner that you might see sometimes if you're looking at articles, it'll say either a minus or a -2, 3, 4. That's just the charge state, or it could be a +2, 3, 4. And the small number on the bottom, that O4, 4 just refers to the number of oxygen atoms in that ion, that sulfate ion. So that's all that means. We don't need to go too far into it. I'll talk about the ferric and ferrous iron later on. I'll do a slide about iron, but the take-home message there with the ick and the us at the end of that word is just, again, referring to the charge state. The ferric iron refers to iron +3, ferrous refers to iron +2. You might see that when you're looking at articles about well water quality, softeners, and treatment options. So I figured I'd mention it just to give you an idea of what that actually means from a chemistry perspective. And the last thing not directly related to chemistry as a concept, but related to drinking water, maximum contaminant levels are the regulatory numbers. It's the highest concentration allowed in drinking water. So that's your enforceable regulatory standard. So we'll talk about those two as we go on. Next. And a brief note on units of measure. I'm not going to get too far into the weeds on this, but these are not usually very common in America when we talk about weights and volumes. In the lab in science, we use grams and liters. So just to provide some perspective for you, I'll go through this briefly. And really, the take-home message here will be the scale of what we're talking about, the magnitude of what we're talking about. These are going to be real small quantities. So a kilogram is 1,000 grams. It's about 2.2 pounds. 1 gram is about the weight of a standard paper clip. So a gram broken down into 1,000 parts is milligrams, right? So 1 gram is 1,000 milligrams. And similar, a liter can be broken up into 1,000 milliliters. So a liter is about a quarter of a gallon. And a milliliter is like, it's like, I think 6 drops of water. It's a few drops of water. It's a very small amount of water, a milliliter. But when you put those together, when you put that unit of mass and that unit of volume together, you get a concentration. So for example, milligrams per liter is commonly written as parts per million. And what that means is literally just the number of actual milligrams of chemical dissolved in that liter of water. So it's an actual amount that you could potentially like weigh out on a scale. But in common terms, a lot of times you'll see parts per million. They're exactly the same thing. And if you go an order of magnitude below that, you get to micrograms per liter or parts per billion. And then again, below that, you get nanograms per liter or parts per trillion. So just giving you an idea of the scale of thing, we're talking several orders of magnitude difference between these units of measurement. So 1 ppm or milligram per liter is 1,000 ppb or micrograms per liter, which is actually 1,000,000 parts per trillion or nanograms per liter. So keep that in mind as we move through these and talk about MCL values and things like that. Things with nanograms per liter MCL values, actually, that's such a small amount that's regulated in our water supply that can actually affect your health. So that gives you an idea about how toxic some things can be. Next slide. This summary slide, I'm gonna breeze through pretty quick. I'm gonna talk about a lot of this stuff in my upcoming slides, but not all of them. But I do want to point out some things that are important when you're considering your drinking water. I'm not going to talk too much about lead today, but lead is a toxic metal. There's no safe level of lead, and there are federal and state guidelines depending on where you're from. In well water, a little bit less of an issue than in municipal water, but still can be found if you have copper pipes with lead solder or something like that. We'll talk later about arsenic, nitrate, manganese, and chloride, iron, and sodium. A lot of these chemicals listed here are naturally occurring, and so sometimes we expect to see them in the water, but at certain levels we might suspect either there's specific geological formation occurring under there, or maybe some anthropogenic sources. What I'm not going to talk about today are radionuclides, uranium, radon. I personally don't know a ton about them, but in maybe Steve would know, in well water, I don't expect to see them cropping up. And disinfectants and disinfection byproducts. Generally speaking, we talk about that when we think about municipal water supplies. So I'm not going to cover those too much, and I'm not going to cover organic things just in the sake of time. Organic in a chemistry term, meaning anything with a carbon bond in it. But those are things like pesticides, herbicides, things like that. I will talk a little bit about PFAS though. These are essentially some of the things that are regulated in drinking water and potentially could come into play for your well water. But let's get started on the next slide here, which I believe is talking about hardness. Yeah. I'll start with things that maybe aren't necessarily bad for you, but could potentially cause problems, and then we'll transition into the things that are a little more concerning for your health. So water hardness, the simple definition is the sum of magnesium and calcium concentrations in your water. So this is what leaves behind those chalky white deposits on your glassware or on your faucets, like the picture there. You know, I grew up with hard water. You see it all the time. It's unsightly. It can cause some buildup. It can cause you to have to replace some of your fixtures or hot water heaters, but it is not harmful to your health. In fact, calcium, magnesium are nutrients that are actually good for you. You need some amount of calcium and magnesium. So not necessarily bad for you, but can cause problems, especially, I know my parents got sick of throwing away hot water heaters, so they eventually got a softener. So general guidelines, if your water's, I took these from the USGS, if your water is above 60 milligrams per liter as calcium carbonate, so that gives you an idea of how we're measuring and what we're measuring for. Milligrams per liter is sort of our scale that we're looking at, and the units being in calcium carbonate, which is essentially limestone, is telling you what's contributing to that hardness, is that calcium carbonate mineral. And anything above about 120 is considered hard. So you might see these if you're talking to a water quality treatment person, or if you're investigating whether or not you need to get a softener. These might be the kind of things they start talking about. And when you see this alternate form of measurement, the grains per gallon, kind of threw me for a loop when I first heard of it. I had to actually look it up. It's an old way of measuring hardness, but it's still in use today, but it's measuring the same thing. It's just different units. So it's still referring to how hard the water is. So anything above about 7 is going to be considered hard. Next slide. So we can remove the hardness with a water softener, and I see the slide got a little distorted there. That's odd. So the way water softeners work is through ion exchange. So again, we have ions in the water, and we're going to be exchanging them out. So when we fill the brine tank with salt, again, salt is sodium chloride, we build a briny solution, and we run it through these little resin beads, and those beads have negative charges. And so what that means, think like magnets, that oh, I think I might have a typo in here, because that should be called positively charged sodium. So that should be a positive charge. The positive charge on the sodium is going to be bound to that resin bead, that negatively charged resin bead. And then when your hard water comes in with all the calcium and magnesium in them, those are positive charges. They're going to actually kick out that sodium. They're going to take the place on that resin bead, and that sodium is going to be replaced or exchanged out, and that's going to go into your drinking water or your shower water or whatever. That's going to go into your house, and those calcium magnesium ions are going to be left in the resin. And then the softener regenerates itself by pumping more brine through there. So that's sort of just a quick overview of chemically how basically a water softener works, but it does put sodium in your water, but it gets rid of that calcium and magnesium, and you don't see those deposits anymore because sodium doesn't form deposits. Next. Related to hardness is alkalinity. You may have heard the term alkalinity. It's essentially just simply the acid neutralizing capacity of a water. It tells you how resistant the water is to pH changes. So if you have high alkalinity water, not highly alkaline water, that actually means something different, right? Alkaline referring to basic conditions, but water with a high alkalinity means it's very resistant to pH changes. And again, we express that in units of milligrams of calcium carbonate per liter. So you can see how this would be related to hardness. There's a relationship there because they're essentially measuring different properties of the same thing, that calcium carbonate mineral or that limestone. And a quick note about pH. We probably all heard about pH, and it basically tells us how acidic something is. The definition of pH is actually the concentration of the hydrogen ions in water. So you're measuring hydrogen ion, and it's on a log scale. The reason I put that formula there is just to show It's the negative log of the concentration of hydrogen ions. What the heck does that mean? Basically, it just means that we're on a logarithmic scale. So that means every step in the pH scale is actually a 10 times concentration change in those hydrogen ions. So if you go from 7 to 6, it's a 1 unit on the pH scale, but it's actually a 10 times change in the ion concentration. I pulled a few quick interesting facts off the internet here. I was reading a paper that looked at the acidity of drinking products available just on the shelf at the supermarket. And considering that teeth corrode at a pH between 2 and 4, and acid rain is right around 4.4 or 4.2, Gatorade and Coca-Cola are actually much below that sort of threshold. They're in the same similar range as stomach acid. So some products can on the shelf actually be quite acidic. But what does it mean for our drinking water? It means that potentially if we have low pH water, it can cause corrosion in our pipes or faucets or hot water heaters and things like that. And if you do end up with corrosion, it's not going to be all at once, but over time it can start corroding your pipes. And if you have copper pipes with lead solder, you can start ending up with copper and lead in your water. So it is something just to keep an eye on. There are some secondary standards for drinking water. 6.5 to 8.5 is kind of that range where you want to be, where you're not going to see corrosion. Next slide. I took these pictures actually from some samples that my predecessor left me, showing some buildup in pipes. And the top one I'm pretty sure is calcium carbonate, and the bottom one I'm not sure exactly what that is, but it looks like iron. It's very rusty. Some iron-containing minerals there. So when water has lots of dissolved ions in it, a lot of dissolved stuff, like calcium, iron, magnesium, chloride, sodium, manganese, all these different naturally occurring elements, it can start to cause the scale formation, and it can cause a bad taste as well. And the way we measure that in the lab, if you want to see just the amount of quote-unquote stuff that's dissolved in your water, we do a test called total dissolved solids, or TDS. There's a limit. Basically, the EPA said anything above 500 milligrams per liter is going to probably start causing some nasty taste. So that's why it's a secondary standard. It's not necessarily bad for you to have high TDS water, but it can taste bad. And all TDS tells you is basically you take a sample of water, you filter it, and you evaporate it out, and you look at the stuff that's left over. You'll get like a film, like a salty looking crust at the bottom of your dish, and that's how much stuff is dissolved in your water. One of the primary culprits here is calcium carbonate again, and that can actually be beneficial. So maybe not to the extent that we see in these pipes where they're getting clogged with the amount of scale, but when you're talking about a municipal water supply, some scaling is beneficial because it prevents the pipes from corroding. But it's a fine line to walk, you don't want too much. Now in municipal water, this is something they look at a lot. For well water, probably less common to have an issue with this. But this is sort of the crux behind the whole water crisis in Flint, Michigan, where they sort of infamously switched from their lake water supply to the river water supply and didn't account for the change in water chemistry. And it turns out that the water was slightly corrosive, and it corroded away all that scale formation. And then it started corroding away the lead pipes, and you started getting lead in the water, among other things. So it can be important, but again, maybe not as much of an issue with a well, but something you might see in your fixtures. Next slide. Going along these same lines here, iron is naturally occurring. It's very abundant. It's the fourth most common element, or fourth most abundant element in the Earth's crust. So we tend to see a lot of iron in well water. I had a lot of iron growing up. It doesn't harm your health. Again, it's a micronutrient. There is a secondary standard that the federal government put out to basically indicate that above this level, you might start seeing these rusty red stains, or you might start tasting some foul, bitter sort of taste in there. And it can promote certain types of bacteria that can contribute to some clogging in deposits. And this is, earlier I was mentioning ferric iron and ferrous iron. Well, ferric iron in the +3, Fe+3, it's insoluble, and that's what's depositing on your tubs and on your sinks and causing that discoloration, that reddish-orange discoloration. That can, since it's already precipitated out, it's a solid, it can be filtered, but your ferrous iron is actually dissolved in water. So it actually can be removed by a water softener, which I actually did not know, but a water softener can remove ferrous iron if it hasn't oxidized yet, because it's dissolved in the water. Once it contacts oxygen, it loses an electron and becomes Fe+3, and it precipitates out, and then you're going to start seeing those deposits. Next slide. Manganese is interesting because it is only a secondary contaminant. So there's only a secondary limit of 0.05 milligrams per liter. Canada does have an actual, they call it maximum acceptable concentrations at 0.12, but as far as I know, we don't have a federal limit for manganese. Manganese, not to be confused with magnesium, which is another element that's actually beneficial. Manganese at low levels does not cause any harm to you, but at high levels it can. It can cause this sort of black coloration in the water, and it can also cause some health effects that affect your nervous system. It mostly is naturally occurring, but it has been used in some industrial processes like steel or gasoline industries. But the takeaway here is that you might look to your state's regulatory agency to look and see if the state has set an MCL, like Illinois has set an MCL at 0.15 milligrams per liter. So if you're getting your well tested and you're concerned about manganese, or if you get a metals test and you have lots of results and you look at your manganese, you can look up the EPA secondary contaminant level, but you can also look to your state to see what levels they have for your state, to see what their guidelines are. Next slide. So I'm going to start getting into the more serious aspect, the more serious health effects here, and we're going to start with arsenic, because arsenic is naturally occurring in geological formations, especially in Illinois. Like Steve mentioned, the Water Survey did a big study on arsenic in groundwater and found that certain aquifers do have a fair amount of arsenic in it that can be hazardous to your health. So it is good to know if your area has high arsenic, and then you know what to test for. It can also be used in certain industries like mining, animal feed. I know rice tends to have high arsenic. So the EPA has set an MCL of 10 micrograms per liter. So again, thinking about the scale, 10 micrograms per liter is orders of magnitude lower than the milligrams per liter that we talked about with iron. So indicating again that this is a serious toxic metal. And because it can cause some developmental defects in children, certain cardiovascular issues, diarrhea lesions, even some odd things like diabetes, ocular effects or eyesight problems, and eventually cancer. So even though we've set a low MCL for this, arsenic is a bit of a concern because it can accumulate in your body, the process called bioaccumulation. So over the years, as you drink water or eat food, some things like arsenic can accumulate in the tissues of your body and cause effect later on in life. So this isn't something that you're going to notice right away. Again, like Steve mentioned up front, you can't smell or taste or see arsenic, and even the health effects can take years to show up. So it is, again, important to have your well tested, especially if you're in an area that might have naturally occurring arsenic. I don't tend to get too much into the treatment of things, but arsenic can be a little tricky from what I understand. But certain filters or reverse osmosis systems can do it. So this is a case where a water treatment person would be consulted. Excuse me. And I pulled a couple articles just to show that we're aware that arsenic is a problem, but it still crops up every now and then. The article at the top is from July last year at the University of Illinois in Chicago, found arsenic in private well water having some birth effects on children, low birth weights, even at low levels. So again, importance here is on testing. Next slide. Nitrate and nitrite are both naturally occurring ions in water, and they're essential for plant growth, which is why we see a lot of nitrogen being applied to farm fields, and manure and human waste as well is high in nitrogen. So that's why we spread animal waste on fields to fertilize the crops, but it can cause runoff concerns. And nitrate and nitrite, relatively high MCLs, nitrate at 10 milligrams per liter and nitrite at 1 milligram per liter. Again, they're naturally occurring, so sometimes you might see low levels, generally considered not a health problem, but especially if you have a baby in the house, it would be a good idea to get your nitrate tested just to make sure, because this can cause methaglobinemia, which is essentially that the nitrate or nitrite can essentially replace the oxygen in your hemoglobin molecules, and that's what's transporting oxygen to your body. So essentially your body's getting starved of oxygen. And I also read that there could be some concern about thyroid disease and colon cancer with high nitrate exposure. So again, it's something to consider if you're thinking about getting your well tested. It's not something you can see or smell or taste. So the only way to know would be to get a real lab test here, especially if you're in certain areas, or if you suspect you might have a problem with your well or your septic, and you might suspect you're getting some kind of contamination coming in. It can happen. It happened to my aunt in upstate New York. She had high ammonia in her well, which was odd, and she was in a very agricultural area. So sometimes this stuff can happen. Next slide. I'll talk a little bit about PFAS, just because they have they've been in the news a lot lately, and for good reason. They're highly toxic. But I'm not a PFAS expert, and in fact, I consulted with a colleague of mine, John Scott, from a sister agency here at the Prairie Research Institute called Illinois Sustainable Technology Center, and he was kind enough to lend me some slides and information to help me put this together about PFAS. So PFAS generally means per and polyfluoroalkyl substances. So what the heck does that mean? It means that these are a bunch of man-made chemicals that were made for certain special properties that they exhibit. And this diagram here on the right, those black lines where they intersect means there's a carbon atom. So there's a carbon atom bonded to a bunch of fluorine atoms. And then there's some other things in there as well. But that's kind of indicative of what we're talking about with the PFAS. So polyfluoro means the fluorine atoms, poly, many. So many fluorine atoms on these. They're primarily used in firefighting foam, AFFF, it's like aqueous firefighting foam. They're used in Teflon manufacturing, food packaging, waterproofing, lots of different stuff. And because they were man-made, there's over 5,000 different types of them manufactured. So you might see other terms like PFOS, PFOA, PFAS. They all mean essentially the same class of chemicals, but because chemical engineers are really good at playing with the chemical structures, they've made thousands of different types of them. And you may have also heard in the news forever chemicals. They're referring to this as well, because they do not degrade in the environment. They're very difficult to destroy. And that's actually contributed to the problem as well. Apparently since 2009, PFOS and PFOA were no longer produced in the US, but two things. They still persist in the environment to this day, and the things that they got replaced with are basically the same thing. So again, there's 5,000 different types of them. So there's many, many types of them. So looking at any one chemical is not going to give you the whole picture. And they've been around since the 1940s. So potentially they've been around for 80 plus years. And they can also bioaccumulate. So certain Army bases have been in the news about having PFAS contamination because they were using this firefighting foam a lot on certain Army bases or near airports to put out the fires. And if that gets into the soil, into the water, into the storm drains, it can potentially get into your drinking water. And as you drink it, it can accumulate in your tissues. And again, there's serious health concern because they can cause cancer, among some other things. Next slide. The good news is that the EPA at the federal level is proposing new regulations, which I copied into this table here. And on the right, you can see what that foam looks like. It just looks like a white foam, but then it sort of, obviously it settles and then it starts flowing across the ground, and who knows where it goes. The EPA for PFOA and PFOS have MCLs that they're proposing at 4 nanograms per liter. So this is even lower than the micrograms per liter. So again, that's indicating to me that these are highly toxic, and at regulating them at such a low level means that there's such a low amount of them that can potentially cause health problems. They can be removed from water through filtration if you have a reliable, good filter. And I'm sure Steve and his resources can provide some information about where to get these kinds of filters, but you're going to want to make sure that they have some kind of certification behind them and have been proven to be effective. Also, reverse osmosis appears to be effective. Next slide. So I'll talk a little bit about bacteria as well, because bacteria can get into a private well. And generally what we do when we test for bacteria, when we're talking about water, is we're going to look at the total coliform bacteria, because they are a broad indicator group that are common in nature because they originate in the intestines of animals and people. So what that means is that it's indicating fecal contamination. The coliform bacteria is a broad group that includes the E. coli, or Escherichia coli. Usually we just call it E. coli. And that's what makes you sick. It usually causes the diarrhea because it's got what's called this Shiga toxin. So you might see that as well if you're reading up about this. But the point is that even if you don't see E. coli in a well sample or in a water sample, even if you just see what's called total coliform bacteria, that is indicating that there's some kind of contamination. So even though it might not be the type of bacteria that make you sick, you still got something getting in there. So it's still a good idea, if you did find a positive test result, to confirm that test result with a follow-up test. You're going to want to make sure that you didn't accidentally contaminate it while you were collecting the sample, or that there wasn't a lab problem or something like that. Because if you do have bacteria in your water, you're going to want to disinfect that water to make sure that nobody's going to get sick. And Steve's group, they're great about offering up resources about how to disinfect a well. And just a point, when you hear a municipal water supply put out a boil water advisory, it's usually because of bacteria, coliform bacteria or E. coli. I worked at a water utility in upstate New York, and it's a regulatory requirement that if they get a positive test, if they get 2 positive tests, we were required to put out a boil water advisory. Luckily, we never did it when I worked there, but it was because of the E. coli. So boiling your water will kill bacteria, but importantly, it's not going to get rid of arsenic, it's not going to get rid of lead, it's not going to get rid of the other chemical constituents, because the chemicals do not get destroyed just by boiling. The bacteria does, because it's a living organism and you're killing it by boiling it. But you can actually make, when you boil water, you're evaporating some quantity of that water. So you're actually concentrating it. So if you had, for example, arsenic in your water and you boiled it and you reduced the volume and then you drank that reduced volume water, it's the same amount of arsenic, but in a smaller volume. So you just made things worse by having a more concentrated solution of arsenic, essentially. So just a point to keep in mind. Sometimes we get this question as well. Should I boil my water? Well, no, not unless you have bacteria. But if you're at that point, you should probably be in touch with a water treatment person or a public health department to get some advice. Next slide.
Hey, Evan, before moving on, your last bullet down there, certainly if there's any kind of contamination, they have to issue a boil order. But I think more typical is when there's a water main break.
Yes.
And that's because it's no longer a sealed line. And so as a precaution, a lot of times you'll have communities issue a boil order where they repair that. And as our infrastructure gets older, we see more and more of those happening at municipal water supplies. Sorry to add that.
Sure, that's a good point to make, Steve. Yeah, it's like a precautionary thing. It's no longer guaranteed to be sanitary, so they do issue those. And the lines do happen with the aging infrastructure, especially in spring. So we're getting to that time when we might start seeing some water main breaks.
Yeah.
We had a big one open up where I worked. Okay, so I'm going to transition into talking about where and how to get your water tested and what a typical report might look like and sort of how to interpret that. So if you're in Illinois, you can always shoot me an email or give me a call and check out our website. We're happy to help people determine what types of tests they might be interested in and to get a sample kit sent out to them. You can also contact the public health department and they can help you find an accredited lab if you want to go that route. Or you can look on the Illinois EPA website to find an accredited lab. And for people outside of Illinois, the federal EPA website provides information for certification programs and certified laboratories for you to get for you to contact to get your test done. And you can also go straight to the certification body, which the largest one is called the NELAC Institute, which stands for the National Environmental Laboratory Accreditation Council. They're the accrediting body. So they're the ones who actually issue the certificates that says that this lab is a good lab under the rules that they've established. And you can search their database for labs near you. My lab is not accredited. It's something we hope to do in the future, but we don't have that certificate yet. Next. So here's a screenshot of what a typical water quality report might look like if you got a report from us. Typically, what you'll see before this will be a cover letter, and we'll describe what the sample was. We'll confirm who it was from, when it was received, when it was analyzed, sort of those background details. And then what we do, since we know we're testing people's drinking water, we'll provide a statement that says, none of the tests that we performed were above the EPA MCLs. So we according to the results, it appears to be safe, or we might say, well, maybe this constituent or this parameter was above the federal guidelines, so you might want to contact somebody about that. But not all of them give very good information. I remember when my aunt had all that ammonia in her water, it was just this. It was just like this paper that just had the results on it. So she was asking me like, hey, what does any of this stuff mean? I don't know. So it kind of depends on which lab you talk to. But of course, there's resources like Steve mentioned, RCAP and the private well class, and here at the Water Survey, we can provide some resources to help you figure things out. And the next slide, Steve, what we do at the end of our reports, we do a cover letter, we'll do the results, and then we provide this like a table, and there's more to it than this, which just gives you sort of a brief overview of kind of the stuff that I've been going through and links to some websites and stuff. So in my opinion, a good lab report will have sort of a summary statement, easy to read results, and then some kind of follow-up information to help you understand what those numbers mean, because those numbers essentially mean nothing unless you have some information. So that was kind of my goal today with my talk, is to give you a little bit of background information about the chemistry of your drinking water and what that could mean for your health. And I think that's my last slide, Steve.
Yes, thanks. All right, great. And again, if you have any other questions for Evan, use your GoToWebinar, either the question box or the chat box. We've already got a few questions that have come in that we'll get to at the end. So before we move on and get to the questions that we are going to answer today from the questions you all asked when you registered, I want to talk a little bit more about the private well class. It's a national outreach and well owner education program. Again, we work with RCAP and their 6 regional nonprofits. So in addition to those RCAP partners around the country, we also work with NEHA, the National Environmental Health Association, the National Groundwater Association, and the Water Systems Council, as well as we've worked with a number of different extension groups in different states. I currently work with Texas, which has a Texas Well Owner Network, if you're not familiar with it, at Texas A&M through their extension service. And so those are great sources for local information. There's other extensions groups that we worked with, Penn State, Rhode Island, Virginia. I'm forgetting someone. But yeah, oh, Mississippi. Yeah. And so if you're in one of those states, you can look up your extension and the well program. And there's others that have started developing programs through their local health department. Like I just had a call this last week from Louisiana Department of Health. They've got a program. They've got some funding from CDC, and they're trying to extend the message on private wells. So there's all those kind of groups available. And so for our part, again, we kind of do the online side of things. And this is our website. It's just privatewellclass.org. You can click on register for class, and it'll take you to a page to sign up. When you do, it just asks for your first name, what state you live in, and your email address so that we can send you a PDF once a week over 10 weeks. There's 10 lessons. There's a lot of other information on this website. I'll go through a few of those things. I do want to mention that if you work in an area where there's a lot of native Spanish speakers on private wells, there's also a Spanish version of our website and a lot of the videos and information we have. And so we can certainly share that information with you. If you go to our webinars and events page, you'll see the upcoming webinars, and this is a dated slide, but below that are the past ones. So every one of these, like today, is being recorded, and so it's available then on our website. And I want to mention a few. We have done 2 webinars on lead. We actually had Dr. Kelsey Piper from, she's now with Northeastern, but she was at Virginia Tech when she did a lot of lead work in private wells. Virginia Tech was involved with, actually, they discovered the lead problem in Flint. So they've done a lot of work in that field. And so this webinar, even though it's from 2018, really highlights what a well owner needs to know about lead. And again, lead is not coming from the groundwater. It's coming from your pipes, your connections, typically because your water is corrosive or aggressive. And so if you have an older home, lead-free really wasn't lead-free until after 2014, at least for solder. And in most states, lead pipes were used until the 80s, or not most. In some states, lead pipes were used until the 80s. And so if your home's older than that, then you should check and find out what kind of pipes you have. And a water sample will quickly tell you, as Evan brought up about scale problems, Flint had a scale problem. And then they switched their water supply and their water went more corrosive. And then that ate away all the scale and started leaching lead out of their pipes. A lot of folks have lead pipes, but their water's not corrosive or aggressive, and so they don't have lead in their drinking water. And so you don't know that unless you test, right? And so that's kind of the message there. We also have a series of videos that are 4 to 6 minutes long on a particular topic: what to do after a fire, what to do after a flood, what should I do, what should I know about sharing a private well. This is a huge issue all over the country, where someone has a farmstead and they build 3 homes for their kids, so there's 4 homes on one well. Now it's 50 years later and they're all separate and different folks who live there, and they all there's no written agreement. And we see, I get a fair number of calls every year about, I share my well, this person is doing something I don't like, what can I do? And you know, it's worth understanding, if you're on a shared well, why you need to protect yourself, especially if the well is not on your property. Unless you have some written agreement, you may wake up one day and find out that the person you share a well with is no longer going to share it with you, and that's be a terrible feeling to have. We started a podcast. It's more for professionals. It's just, the website is drinkingwaterpodcast.org. It actually deals with both. It's called the Drinking Water in Rural America podcast. And so I've highlighted 2 of the folks who've done private well work. Judy Manners is actually with Tennessee Department of Health, and she works a lot with springs. But springs are all over the country, and a lot of people swear by them, but they're also very contaminated. And it's some of the sampling she's done and information she's found. And the bottom one is Brian Swistock, who just retired last year from Penn State. He is by far the most knowledgeable private well person I've ever met, just plain and simple. And he worked there for nearly 30 years, developing an education program for Pennsylvanians. And it was a really good talk about a lot of things they've tried and done, and the issues of private wells. We also interview doctors and public health folks, water, community water supply, and even wastewater folks. So it's kind of about helping small systems and private well owners. So yeah, you can find it there. If you're a professional, we have a newsletter. It's really not geared towards well owners. It's more providing information to our partners, if you will. You can sign up. There's a newsletter page, and we highlight, this is a well sealing demonstration that we were involved in of an old dug well. And we've held 4 conferences now, and 2017 and 2019 were in person, and all of those were recorded and video was shot. And so those are also available on our YouTube channel. We brought in people to talk about practical problems well owners have. Like Todd Giddings is he's a hydrologist in Pennsylvania. Pennsylvania is one of 2 states that doesn't have well construction code and doesn't license drillers. And when I say doesn't license drillers, anyone, you, me, my daughter, can all send in $60 and get a well drilling license in Pennsylvania. There is no continuing education. There's no test to take. Even on their website, they say having a license in Pennsylvania doesn't mean that you have the knowledge or experience to actually drill a well. And I say that because one time somebody from Pennsylvania questioned me on that issue, but they passed an ordinance in their area, local area, to require well drillers to have certain kind of skills before they let them drill a well there. And that's what he was there to talk about. Really interesting stuff. All of the presentations are about ways that if you're a professional, you can work with well owners in your jurisdictions and provide more information to them. So the goal of our program really is these 3 things: to help well owners understand why their well is important, why they need to really understand how it works so they can make better decisions, and use all of that then to help protect themselves from risk of poor drinking water or water quality problems. And so, our program has a class, it does webinars, we have videos, all those things we answer, or we have a phone line, and it's all towards this one goal. As someone who grew up on an old dug well, it's rewarding to be involved in this type of program, and it's all free. So we got a bunch of questions, as I mentioned, I think over 90. And so we're going to answer some of those now, like we do every month. And if you have other questions, you can put them in a question and chat box. Katie's going to look at those and put those in a Google document that I can slide over and put on the screen at the end. I do want to mention that we answer questions every month, 10 to 15 questions. I try not to answer the same questions every month. And so if you go back through our past webinars, and even if one of them we have is like Well Owner 101, if you go to the last 3 of those over, say, the last year and a half, the questions at the second half of that will be different, even though the other content is identical. The canned slides are identical, but the questions are going to be different based on what people ask that time. And again, trying not to answer the same questions every month. And so it's really worth while to do that if you're interested in learning more about well issues that other folks have, because we find that's one of the best parts of these webinars is real world questions that we get about specific problems, sometimes really off the wall ones, a matter of fact. So a few of these Evan's going to answer, like this one. And so the question is, what to test for specific to an area or state? Should I be testing for something I'm not aware of that's not on a standard test? Like, what are the accepted standard chemical levels? Are they the same as healthy levels? Evan?
Yeah, we get this question a lot, and in the questions that were sent in, there were several that were very similar to this, and the answer, unfortunately, is that it depends. It depends on a lot of different things, like I talked about at the beginning of the webinar, but it also depends on, like in this example, if you're concerned about your health, then maybe you don't need to worry about testing for things like hardness or iron, but you might want to focus on things like arsenic. Or if you're concerned about lead pipes, you might want to get a lead test. So it kind of depends on what you're concerned about. It depends on the geology and the aquifer and the well construction and all that other stuff as well. It also depends if you're having symptoms, which if you are, please go to a doctor. I am not a doctor, I'm an environmental scientist. So I run a lab, I can't help you with medical issues. But if you're getting discolored, stinky, or foul-tasting water, or if you have mineral deposits, then that's going to indicate that we should test for certain minerals versus if you know that your aquifer has a high, like arsenic, like in Illinois, the certain aquifer has known to have high arsenic, maybe you just want to get that tested. So it's a good idea to talk to a local geological agency, like in Illinois, the Illinois Geological Survey, Public Health Department, Environmental Department, or a local USGS office. So they're the people who are going to be able to help you understand the geological and aquifer, makeup that your well's in. One thing that I tell people when they ask, like, oh, geez, I don't really know what I should be concerned about, I say, well, we can do a test called metals, and we use a machine called an ICP OES, and it essentially tests for 30 metals at the same time. So if you're concerned about that kind of thing, it's a good broad spectrum test because it includes manganese, arsenic, lead, copper, calcium, and a bunch more. So that's kind of a good first step. But again, it's if you're concerned about being near a PFAS contamination site, then this isn't going to help you. So unfortunately, it depends. And there's people out there that can help. And of course, here in Illinois, we're here to help as well.
Yeah, I added manganese, arsenic, lead, and copper because those are the most common things that people ask about. Mm-hmm. And as far as manganese goes, Evan mentioned that it's a secondary contaminant. Well, it was listed that way in the 90s in the Safe Drinking Water Act, but there's been research done in the last 5 years that indicates that it causes neurological problems. And so he also showed that Canada has already created a health limit. A number of states have for manganese, and even though there's not a federal standard, a number of states have already created one, and it's very common. It's just like iron. Most groundwater, especially in Illinois, has both manganese and iron in it. And so, it's something to take seriously especially if you have children. I mean, I'm going to talk a little more about what people can do, especially the first question up here about what to test for, because, part of this is on you to be inquisitive. Like Evan mentioned, talk to a local agency or whatever. And I'm going to give you a couple examples that I share a lot of times about that. So this is Rhode Island, and this is on the Rhode Island Department of Health's website. And the point is, be inquisitive. Check out these resources. There may be information that's really valuable there, as well as determine who the contacts are, so that you can, if you come across a question, you know who to contact. But I want to point out the big splotch. The little dots are all where there used to be orchards, and they know there's arsenic contamination in the soil. And if it's shallow aquifer in those areas, it could also be in the groundwater. But that big splotch in the middle is naturally occurring beryllium. No one tests for beryllium, and like in Illinois, it's not considered something that you'd find. It's kind of a rare occurrence, honestly, but it's, you know, a third of the state for Rhode Island, which is small. It's 30 by 40 miles. But it is a regulated contaminant. It has an MCL. And, you know, I would have never known this if I hadn't gone to their website just to check it out and see what information they had, which I did that like 10 years ago. And I've used this slide ever since because it's a great example of why you need to take care of yourself. You need to go look and see what, you know, there's maps for arsenic, uranium. Certain states have put those things together. The Water Survey in Illinois has done a lot of that. You know, because of our public service lab, we have a lot of water quality data, and we've been able to go out and find those things. New Jersey passed a law nearly 20 years ago requiring a water sample be collected at any home sale that has a well. And because of that, they collect 13,000 samples a year from all over the state. And if you go to their website, there are awesome maps that show where they have naturally occurring contaminants in every part of the state. So be inquisitive is a message, as well as find out who the contacts are, and don't be afraid to call those folks and ask them for help. You know, I live in this county or this area. Is there anything I should be aware of? You know, if you're in the center of Rhode Island, they're going to tell you, well, you need to be aware of beryllium. And even though that's not on a standard test, typically you're going to want to do that. There's also, this is from Wisconsin DNR. They're the regulatory agency for community water supplies, non-community water supplies, and private wells in Wisconsin. And they have this tool online. It's a, you know, it's a web map. I clicked on arsenic by county. And so it's showing me which counties have arsenic. You know, the standard is 10 parts per billion, as Evan mentioned earlier. And this shows if it's, you know, the green ones are less than 5 micrograms per liter, which is half the standard. But those 3 red ones by Green Bay means the average private well sample they've collected is over 20. And, you know, take this with a grain of salt. I'd contact them just the same, because you see there's some of these counties are clear. They only have the background topography. And that's because they're, at this time when I took the screenshot, there was no data on arsenic for those counties. And I'm sure that's changed today. And so as more data is collected, they add to this database and this gets re-upped. And so there's a lot of, you know, good information. Other states are building these sorts of tools. And so it's a good way to find anything out. You know, if I'm going to move to Green Bay, then at least I know I'm going to, and if I'm going to live in a house on a private well, doesn't mean I won't buy one, but it means I'm going to check it out and test it and make sure there's a test done before I buy. So yeah, they're really useful. Okay, I also want to mention that someone had asked, at what level is hard water a concern with plumbing, and is it a concern in drinking water? Well, Evan already mentioned some of this in terms of what's hard, very hard, blah, blah. But in terms of scale formation, one, as Evan mentioned, it's not a health concern. But, you know, once your hardness gets above some of these levels, you can expect a lot of scale, is the bottom line. And we see a lot of hard water and groundwater, and that's just the way Mother Nature made it. Okay, Evan, this is for you. Is there good tests to buy online, and would you name a few?
Right, and I've run into this as well, Steve. So people have asked us as well. In fact, researchers on campus have asked me about test kits, and I pretty much tell people I caution them against using them because they are either inaccurate or unreliable. Especially if you're talking about investing like a large amount of money in something like a water softener, or if you have a question about your health or your family's health. Don't take the cheap way out. Get a test done by a reputable lab. That's the only way. There's really no substitute for getting a water test done by a certified water testing lab. I usually describe it to people like this. If you want to know if there's a little or a lot, a test kit might be useful for you. But if you want an actual number and you want to have confidence in that number, you need to go with a lab. Now, if you wanted to do some kind of screening, or if you were testing your pool water, yeah, the strips might be sufficient, but I would suggest, if you're concerned about something, really have a lab test that parameter, or if you do a home test, have a lab confirm those results.
All right. Yeah, we've not found, as a screening tool even, there's more false positives, more false negatives with those kind of kits than there are if you take it to a lab. And it really, if it comes down to you're using that to decide your family's health, it's probably not a good idea. Okay, what is X chemical indicating? So the actual question was, what is elevated bromate levels a possible indication of? Evan?
Okay, so the reason I said was X chemical, because we get sometimes this question too. I have high this, what does that mean? I'm not a public health person, so I can look it up for you. I can help you find resources, but a doctor would probably, or a public health agency would be the best person to talk to. But this question specifically said, I have, what is elevated bromate levels a possible indication of? Well, this potentially is a question of terminology, because bromate, BrO3, actually I made a typo, that shouldn't be a capital R, that should be BrO3 with a lowercase r. But anyway, it's a bromine compound that's bound to 3 oxygen atoms, and that's different than bromide, which is bromine with a minus charge. So that's an ion that's commonly found in drinking water or in surface water, groundwater. It's a common element that's found in water. Bromate is a disinfection byproduct, especially when ozone is used to disinfect the water. So think municipal water systems, and is a probable carcinogen. Okay, so these are very different, because bromide is naturally occurring ion. It's generally low in most waters, and there's no federal regulation that I was able to find concerning bromide. So while I was searching, I found that bromide could indicate some contamination from mining or coal plants, or even from salt water, because seawater would be high in bromide, but it's not by itself a health concern. So on the other hand, bromate is highly regulated with a maximum contaminant level goal of 0 and an MCL of 0.10 milligrams per liter. So I question whether or not this person meant bromate or bromide, because if we're talking about private wells, I don't know why you would be seeing bromate in there unless you had maybe an ozone system installed in your house, which would be pretty serious treatment. But do keep in mind that as you go doing your research and looking things up online, that the terminology does matter with chemistry. Maybe not in everyday life, you can let it slip by here and there, but in chemistry, things like this, just 1 or 2 letters in a word is going to make a big difference. And with that said, I find that the US EPA, state health and environmental departments, the CDC, and some of the other government agencies like the USGS are really good resources for learning about this kind of stuff. And it takes 2 minutes to Google it, and they'll pull up probably 5 really good articles by these reputable government agencies. So if you have a test report, like I mentioned earlier, some places will include some explanation, but if they don't, I'm sure that there is a local agency near you that can help you understand the report. But to answer the question, bromate is an indication of a disinfection byproduct when bromine and ozone react in the water with organic chemicals to form bromate, and that's a carcinogen, and that's bad. You don't want to drink that, but I question whether or not that was the case in this, but yeah.
Okay. So there are things out there, and and you'll find this in other webinars where I've mentioned there are tools out there to help you interpret results, but just case in point, they're only a guide for typical waters. You should always take your sample results to your local health department or your doctor to get a qualified answer. And yeah, at least in most of the country, if you take a sample, a result in that shows something high, it doesn't mean they're going to tell you can't use your water or condemn it. I ran across 2 health districts in Connecticut where they actually have that authority, but in the rest of the country, I've never seen it. And so if you're worried about something like that, like someone telling you can't use your well anymore, then you can call them first and ask what kind of authority they have, and find somebody else to ask that doesn't have that authority. And that's just to protect you, because you should be able to make a decision as a well owner about what you do with your well, in my opinion. So there's a tool that New Hampshire developed, the state of New Hampshire DES. We actually had them talk at our 2017 conference. If you want more information about it, you can find the talk that was given on YouTube, on our YouTube page. It's called the Be Well Informed tool. Since then, after we did this at our conference, a bunch of states that were there asked for the code. And so ECOS, the Environmental Council of the States, which advise many federal agencies, and the membership is a environmental lead at some state agency in every state. They've taken this over and now allowed states to create their own version, like New Hampshire's. And these are the states that are listed here, as well as Wake County, North Carolina. They have the wherewithal as a county to get involved in this. It'd be great if all 50 states were included, but it's just bewellinformed.info. If you go to that webpage, I'll show you what you can do. It pops up, and I did New Hampshire. I don't know if you can see that in the grayed out area there on the left, but I picked New Hampshire, so it allows you to put in your sample results. And why this is better than some of the other older ones that are out there is because, one, it allows you to pick your units. Evan put that slide up showing all those units. In our private well class, we ask everyone to take a pre-test and a post-test. And one of the questions is a conversion from, I think it's from milligrams per liter to parts per billion. Only 27% of the 10,000 people that have taken our class got that question right. And I'd be the same way. It's easy to slip units. Math's not my strongest suit. But the point is, when you get a lab result, sometimes they're all been converted to milligrams per liter. Sometimes they're not converted. And I think actually the sample example that Evan showed from our lab, a number of the things were in micrograms per liter. We put them in the common units that they're usually discussed in, if you will. So I typed in 15 parts per billion of arsenic, which the standard is 10. And so what I got back was arsenic at 15 micrograms per liter, the limit's 0.01 milligrams per liter, which is 10. And so I got a red X. But the other thing that's nice about this is if you scroll down this page, it tells you what kind of treatment will remove it. So no matter what the constituent is, they give you options and let you know what you need to do. And so you're not relying on someone who may have an interest in selling you a bunch of equipment or any of those things. And there's also, if you click on resources, there were 3, I'm gonna go back. You can see I'm on results tab, the entry tabs where I put the stuff in. And if you go to resources, this is for New Hampshire again, but it lists all these different programs, and there's more as you go down, and who to contact. So if you have a result that scares you or is a concern, a health concern, here's someone to call. And again, this is for the states that I listed there. I think there's 11 states in one county. Illinois is not on there. We hope someday to work with our Department of Public Health to actually get it on there as well. And the reason they've done it this way is it gives every state the opportunity to tailor the resources they provide. So if you are one of those states or in one of those states and you have a sample and want to look, you'll find local resources there, depending on what how how much detail they provided into this tool. So it's really useful, but again, I'll say it again, still take your results to a local health professional because that's still the best way to do things. Okay. I had a new well dug 12/20/22 in Plainfield, Massachusetts, 180 feet deep. The water tastes so metallic, it gags me and I can't drink it. It passes lab test, post-digging test. I am buying and hauling water. What options do I have other than spending a few $100s on a comprehensive test? And, you know, one thing I didn't think about, Evan, whenever I looked at this question in the beginning is they probably have a requirement to test for a few things once the well's installed, and it has to pass that in order to be considered potable and usable.
Yeah.
It doesn't mean that they've done a comprehensive test on their own.
Exactly.
Right.
Yeah, and I didn't mention that either because I'm not well versed in all the different rules and regulations, and I'm sure it changes with states. And I know that if you have like federal, was it veteran assistance loans, that they, I think, require you to test, I think, nitrate and bacteria. But like I said, I'm not sure what that all means. So yeah, they may have done something like that, Steve. But in this case, if something is that bad, like we've both mentioned earlier, it needs to be tested. There's really nothing else that I can think of that you could do to know, is this water safe? If it's that distasteful, it sounds to me like there's really high levels of something in there. And I mean, it could certainly be unhealthy, but it also could be affecting your pipes. It could be affecting your fixtures. You know, I'm not quite sure where to go with that besides the bottom line being it just needs to get tested. And if the money is that much of an issue that it's unaffordable, you might need to shop around or make some phone calls to try to get some assistance.
Yeah, and right. And there probably aren't low-cost testing options, but you are in Massachusetts, which, you know, there's a lot of work going on there through the Central Health Foundation. Let's see, the Health Foundation of Central Massachusetts has been working all over the state, I believe, sampling wells. You know, there's work to try to pass legislation there to make water, to give everyone, to make testing more available, and support like there is for your septic program. I do want to mention now, I knew I had this in here somewhere. I mentioned RCAP has a site assessment program. They've done over 3,000 of these assessments all over the country. But one of the things it includes, you meet with a person in Massachusetts. The guy's name is Jim Starbird. He's a former sanitarian. And if they have room in their program for you, it could include a sample. But they certainly would help you investigate why. You know, in fact, Rhode Island is a very small state with a very small health department. They've asked Jim to do well assessments in Rhode Island when they have a real problem that they don't have the staff to go out and investigate. So that's another option for you. And you can email us and I can get you in contact with him. So yeah, it's a really great program. Okay, testing and treatment funding. So we did get a lot of questions about, you know, affordability is a big issue, especially with, you know, private well, it's been there forever. All of a sudden it needs something really major, like a, you know, an $8,000 pump, or if the screen's gone bad and you need a new well, it could be anywhere from, you know, $10,000 to $40,000 or $50,000. So there were a lot of questions about testing and treatment funding for a specific locality. I live here, I live there. You know, we don't have the wherewithal to look that all up. You should be trying to look that up, for one. But we just did a webinar last month on funding, financing options for private well owners. The one program that's nationwide, basically, is through the Farm Bill. The USDA offers loans for wells, septic treatment, those sorts of things. But it's at 60% of the median household income for your area. And so it's only for pretty low income folks, which makes it not available to a lot of people. But what we try to do in the webinar is highlight other programs that we have found, like Iowa has a Grants to Counties program for testing. And there's other, New Mexico, if you'll register your septic system, they'll give you a free water test. And I mean, so we went through and tried to give people ideas on where they could look locally, like through your soil water conservation district. Some of those have programs for certain things, whether it be testing or whether it be abandoning of old wells. So I encourage you to go, it's on our website. I encourage you to watch this video from last month's webinar. And we haven't done this for like 2 years. We've done it 2 or 3 times. And we brought folks from USDA on to answer questions and talk about it because it is an issue. It's just, not having a water bill because you have your own well doesn't mean you shouldn't be putting money in to the day that you're going to need a new pump or something breaks, or it's just like anything else. You need a plan for that happening. And so the best way to answer most of those questions is to tell you to watch this webinar because we went through it in a lot more detail there. So saltwater intrusion. Treatment ideas for wells with saltwater intrusion. Well, we certainly see more and more communities around the world using saltwater, ocean water to desalinating because they don't have other choices. I mean, I think the largest desal plant in the world is either in Saudi Arabia or Dubai. But even San Diego now has, I think, a 20 MGD reverse osmosis system for removing salt and using ocean water. RO is certainly good at removing a lot of different constituents. That's probably one of your best options. It removes arsenic. We see a lot of folks put in an RO unit under their sink because of arsenic contamination, for instance. But the point I'll make here, and I haven't already mentioned it, and someone also asked the question, I think, or maybe I read it in some of the questions. If you're going to buy any kind of treatment device, make sure it's been certified by a third party. And those labels below, NSF, which stands for National Sanitation Foundation, UL, Underwriters Laboratories, or the Gold Seal from the Water Quality Association, they're third-party certifiers. So like when Flint happened and everybody was concerned about lead, the US EPA research office in Cincinnati did all kinds of testing on different devices. And one of the filters they tested actually removed, it had to remove lead at over 250 ppb, I believe, to get certified by one of these certifiers. And they found that one of them could remove lead to almost non-detectable as high as 1200 ppb. So when you go to look for purchasing a treatment device, if it doesn't have one of these symbols, it might be a third of the cost, but you get what you pay for. And if it's got one of these symbols, that means that company has paid one of these 3 organizations to do the standard testing to ensure that it removes what it says it'll remove. And so the other thing I want to mention is if you have a treatment device or you buy a treatment device, follow the maintenance schedule to the letter that's listed. Don't assume you can let a filter go an extra 2 months, or I don't have to change this out because it looks just fine. One of the folks at the Minnesota Department of Health, when we first started the private well class, suggested, excuse me, we don't even talk about treatment because he found that more people, their treatment devices were causing contamination because they weren't maintained than folks who actually maintain their treatment devices the right way. So I mention that a lot because it's really true. You have to do what it says, and there's like for an RO unit, there's a certain cost up front, and then there's a yearly cost. Same for filters. I showed those filters before. One was black, one was white. That black one is full of manganese and iron, and the guy who has that particular filter has to change it out almost every 2 months. And a small filter that looks like a paint roller isn't as expensive as some other types of maintenance devices or for treatment, but you've got to follow it and understand that there's going to be a cost to it. Okay, so if a well cap gets, and Evan, feel free to step in at any time. I'm going to go just keep going, and if you have something to add, please just interrupt. If a well cap gets knocked off, I think that's supposed to say, should the well automatically be considered contaminated? Sorry about that, shot the well. So we recommend that anytime a well cap is opened, you get in the well to do anything, remove the pump, measure the water level, anybody has to check something, pull some wires, whatever, that you should go ahead and chlorinate, because it's the most likely time that you're going to introduce bacteria into your well. My other question is, if you have a sanitary well cap, a properly sealed cap, how did it get knocked off in the first place? And you can let me know that if you want to email us. But we've seen, everything under the sun that is listed as a well cap, from a coffee can, after you take the top off, just turned upside down, to really a plastic bag duct taped on the top of the well. Those are not a sanitary well cap. The whole point of that is the biggest problem is typically at the cap. In fact, Madison County, New York, their health department did a study. They had some funding to go out and measure, to take water samples from a bunch of wells. And they also noted what was going on with people in their well caps. And there was a huge correlation between the wells that had bacteria problems and the wells that didn't have a sanitary well cap. It's just an important thing. And, those certain types have a rubber gasket. And so whenever you connect the bottom flange to the top cap, there's a gasket that goes in there. If you're in a cold climate or you have freezing winters, over time that gasket gets brittle. And more times than not in Illinois, when I open up a well, there's either no gasket or there's part of a gasket or whatever. And then, bugs can get in, all those sorts of things. So your well cap is important, and you need to consider putting a proper one on top of your well. I have tested my well water myself, and each test has indicated the water is pretty acidic. So my first question just for that part is, have you just done a litmus test and tested the pH, or what have you tested for? So what can I do to best mitigate this? Should I have a certified lab test my water before I install any mitigation equipment? So regardless, you need to have an actual water sample done by a certified lab, in my opinion, to know how negative is it, or how acidic is it? Is it 6 or is it 4.5? Do you know what kind of pipes you have? Where did you take the sample? There are ways to raise the pH. There's neutralizing filters that use calcite or calcium carbonate or magnesium oxide, and those will raise the pH of the water. But you can't really make any of those decisions until you've tested and have an analysis to go by.
Yes.
Another cause. Yeah, go ahead, Evan.
I'll jump in just a little bit from a lab perspective. At least for our lab, pH is one of the cheapest things we offer. So I would suggest also, obviously, yes, I'm pro getting your well tested by a lab, but also the cost associated with a pH is probably pretty low. The only caveat there is that you're going to want to get the test done quickly. So you're going to want to take that sample and then get it to the lab as soon as you can, because the holding time there is pretty low. But what does pretty acidic mean? I agree with you there. You kind of need to know what that number is and how confident are you in that number.
Well, I think you need to also test for other things. When it's acidic, do you have any, it could be a little bit acidic, but you may have PVC pipe and no lead, no galvanized lead or copper. And then is it a water quality? Is it a health concern? Not so much. And so again, all of those things matter. You really need to understand, you know, even if you do have acidic water, there's a lot of groundwater that's at 6. In Virginia, the Piedmont aquifer, the groundwater is naturally at 4.5. But if everything's PVC, then you're not leaching anything from your pipes, right? And so understanding all of that is really important to making the best decision, especially if you're going to add equipment. You know, as Evan said before, a lot of that stuff can be expensive. You don't want to add something willy-nilly and then find out it's not really doing what you need, or that you didn't need it in the first place. I've honestly been in several homes doing well assessments where they showed me all this equipment that they had down in their basement. One guy had over $5,000 of equipment, and I said, "What's in your water that you need all that stuff?" He goes, "What do you mean?" I said, "Would you test? Did you test it?" He goes, "Oh no, we never tested it. We just wanted to be safe, so we did this." Well, that's their prerogative. If you have an extra $5,000 lying around, but if you don't need it, you should have all the information at your in hand before you make any of those decisions. Okay, so I have really good water with minimal odor or iron, although I've never tested my water. Same theme here. My well is used basically for cooking, animals in the yard. I do drink out of the well when in my yard. My concerns are more the testing and what to test for, arsenic in my plumbing. So again, odorless, colorless, tasteless. So you have no idea if you have arsenic in your water without testing. And what we recommend, and I'm going to go through what we've recommended since we started this class, and we had a group of folks help us figure out this is a good basic set of parameters, but you should test annually for coliform and nitrate. And the reason you do that, not because coliform or nitrate itself might be harmful. You know, nitrate's a real problem for babies and pregnant women, but you know, it's not regulated as a contaminant for adults. Maybe someday it will be. There's everything I read says the testing on nitrate. There's some studies that show it could be a problem. Others show that's not the case. And coliform is harmless. It's an indicator bacteria, but the reason we test for those is because they're ubiquitous and so common in the shallow environment that if you have them in your well, it likely indicates that there's a breach in your well or a pathway into your well from the shallow surface. And that's a risk, because if there's something else in the shallow subsurface or on the ground that can get in your well, that might be much worse. And so you use coliform and nitrate as indicators that your well is properly protected from surface influences. But then we also recommend you test every 3 to 5 years for inorganics, metals, and again, any specific constituents that might be possible in your local area, like beryllium if you're in Rhode Island. And so this is what we typically suggest. And I put up here annually for coliform and nitrate. Penn State, Brian Swistock suggested, you know, we start telling people every 14 months, because they're, depending on the type of well you have, especially if it's a shallow well or an old dug well, season matters. You know, if it's the middle of winter every year, it's different than when you have all your spring rains and all that stuff. And so, you know, their take is, which it's hard to argue with, is if you do it every 14 months, then over time you've sampled in every season, and you may find things that you didn't know. But, you know, we suggest this list of constituents here. It gives you a good idea of your groundwater chemistry. You know, Evan mentioned alkalinity and TDS, as well as things that might be dangerous, as, you know, lead or manganese and those things. But again, also get advice from your local or state health department and find out if there's anything else that you might need to test for. What are your thoughts on getting a representative sample from a well that hasn't been used for at least a month, a vacant home, for example? So this is a really common question because so many people have a second home or summer cottage and they don't do anything when they leave, and they come back the next year and they turn on their faucet and it smells bad and there's all those issues. And the deal is, if you're on a private well, then you're not disinfecting the water in the first place. So you're not using chlorine or have UV. Typically, you may have, but a lot of times we'll see bacteria issues if that water's been sitting stagnant. Matter of fact, for some non-community systems, states require those type of facilities that are seasonal, like a campground, to drain all their lines and then chlorinate when they fire everything back up again. And that's really what we would recommend. One, you need to flush every line, and so that you're sure that you've pumped out a bunch of well volumes from your well, because the water's been stagnant in your well as well. And that can be a problem, because there, depending on the type of well you have, it could be in contact with metals, things in bedrock, or whatever. And when you first turn on any of those lines, if there's any air, that means it's not completely full pipes, and you're much more likely to have a bacteria problem. And so what we would recommend is, before you try to take any sample that's representative, that you run a lot of water through all the lines in the house, every single one, just like if you were shock chlorinating, you do that. And then disinfect, do a shock chlorination to ensure that everything is ready to go, so to speak. Yeah. My well contractor never filled a completion report. How do I get my well online? So I wasn't sure how to take this question, because it sounds like you know your well contractor, and if so, then the best thing to do is to contact them and ask them for a copy. What we tell well owners who are going to drill a new well is, have it written in your contract with the driller that you get a complete copy of everything, including the log and anything they file with the state, and anything else that you might want, like the size of pump you have, all those things. If they did a test on what the drawdown was, if they pumped the well, all that stuff. And if the contractor didn't file a completion report, you're not going to find it online. But again, the way this is worded, how do I get my well online? It suggested to me that you might be asking if you want to get a copy online, which, again, not sure. But if you don't have a log and you can't get one from your contractor, don't know who that is, then, well, first of all, if you do know who your contractor is and they're not willing to give it to you, call me, because I think that's something that I would take personally, and I would contact the state. I will work on your behalf to make sure that contractor has a really hard time not giving you that log. I may not be able to get it for you, but I'll put a good effort in. That I can promise, because that's ridiculous. You paid a lot of money for your well, and I have seen that, unfortunately. But if you don't know who it is, are there any well logs nearby? Talk to someone at, like, your State Geological Survey or USGS about the geology in your area. It may be there's only one aquifer, and it's the sand and gravel that's from 120 to 180 feet, and all the wells in the area are on that same aquifer. Then it's very likely that your well is too. So you may have a nearby log that you can use as a surrogate. It won't tell you where your pump's at or some of those things, or the exact depth, but you'll have a good idea where your water's coming from. And it's really about gaining that sort of information. You can always hire a contractor to come out and measure the depth of your well or tell you your pump setting. But yeah, and there's the sad truth is, in a lot of states, more wells than not don't have a log on file with the state or with the county or whatever. And so when that happens, there is nothing to do but try to gain as much information as you can. And one of the things we do is, so we run across folks who want their well tested using Evans Lab, but there's no well log on file here at the survey. We house the state's well logs. All the counties send us a copy of the logs, so we're the repository for all the well logs, private well logs in the state. So if we don't have it, no one does. But if someone gets a water quality sample, we will take that water quality sample and put it with a cover page that describes everything we do know: the owner, the location, everything else we can find out about the well and how old it might be. When was the house built? That's usually a good indicator when the well was built. And we'll put that on file and create a well log for it. It won't have the geology, but it'll have other information, and at least now we've identified that there's a well there. And so that's the other option we might have. And I know that's not totally helpful, but the bottom line is there's a lot of people who don't have a well log, and there's nothing to do about it. than to have a contractor come in and determine the depth and some of those things. But if it's a cased well, you still don't know the geology. There's no way to really get that information. Groundwater under direct influence. So I thought this was interesting. This is really a question that's typically about community water supplies. This GUDI is a term commonly used whenever a community puts their well field in a river bottom where it pumps hard enough that they're drawing water from the river itself into the aquifer that's shallow and near the well. And so this person was concerned. I thought it was worth mentioning. Individual homeowners may have a groundwater under direct influence well and unaware of the additional risks that they present. And that's because river water, surface water, is considered contaminated with bacteria, viruses, all those things. For a public water supply that has groundwater under the influence or uses surface water, they have to treat to, I think it's 4 or 5 log removal of viruses and all those things. And so it's, there's primary treatment, secondary treatment, and tertiary treatment. Surface water supplies need to do all of that, all the way to tertiary treatment, in order to ensure that the water they're serving their community residents is safe. And so what I would recommend for anyone that has their well in a bottom ground, or again, even if you may have a sand point or you're using a spring, those are all likely contaminated all the time. And so you really should look at it the same way. They are likely contaminated with bacteria. They're susceptible to surface contamination and shallow infiltration. So you should be using continuous disinfection. And that means either adding continuous chlorine, not shot chlorination, but having a chlorine feed in your line so that there's continuous chlorine like a community water supply does, or UV, ultraviolet light. And because there's so many people who use springs around the country, there's quite a market for UV systems at the private well level, if you will. They're not just commercial systems for larger use. And so there are UV systems. It's using a UV light, so there can't be a lot of solids in the water. So you have to filter it first, typically. But they can work really well at killing bacteria and viruses and all those things. And you should also be testing regularly. If you know there's if there's any nearby surface influences that could be a problem, like a lagoon or something like that. So yeah, that's my take on that. As far as, that's the last question that we answered in the slide deck, but we have a bunch of questions that people have asked, and so I'm going to bring that over real quick. Tell me if you can see this, Evan, and is it on top?
Yep.
Okay. So we're just going to go through these. It's already almost 3, so we're just going to keep buzzing through. I am using a water softener and note a salty residue on pot covers after cooking. My softener company came to check and said all is fine. Can that be from softener salt? Second question. And Evan, do you have any idea there? I don't really deal with water softeners.
No, I don't either. But it could be. This is something that actually, when my parents did theirs, I said, "Your water's soft. I can feel it slimy." That's
different though than having a salty residue.
It is, but my point is that the softener companies just say, well, everything's working fine, and they might not fully understand what your concern is, I guess. And from their perspective, it could just be that, yes, the water softener is functioning properly, so that's the end of their involvement. So it might be that you might want to get a test done for minerals just to see if that is salt, because if it is, I guess technically it could be dumping a lot of extra salt there. But
so we did. So Evan's predecessor was also on a private well, and he did he sampled his water right before his softener regenerated and right after, and also took samples before the softener, like an outside spigot, and at the kitchen tap after the softener. And like the sodium went from 27 in the raw groundwater to 198 in the finished water because of their softener. And so it certainly is going to increase the amount of the sodium in your water. But as far as yeah, I guess the thing to do would be to collect 2 samples, one prior to your softener and one after, and you can at least look at that information. The other thing we can do is if you'll email us, I can ask someone from the Water Quality Association if they have any ideas. So, and as far as your second question, if you're going to buy your own, I assume that means treatment equipment, then I already answered that. You want to make sure that the treatment equipment you buy has been certified by a third-party certifier to remove what it says it will. And that's National Sanitation Foundation, the Water Quality Association with their gold seal, or Underwriters Lab. So, and you'll notice, like if you go to any website where they're selling treatment equipment, you'll see this long list of like RO systems. And if you sort them by price, all the ones that are cheapest won't have, if you start looking at those, won't have information about a third-party certifier. The ones down below that are more expensive will, and that's just the price of doing business. But again, you get what you pay for. Question for Steve regarding radon in well water and how it's tested for. So if you're the person who asked the question about, you didn't have radon, but you want a sample to see, the head of our groundwater section had actually answered that, and I didn't include it today just because we couldn't include all the questions. But if it tested low before, or you didn't have an issue, you're very unlikely to have it crop up as an issue later. But as far as testing for radon, it's a tricky process, and there's only some labs that do it. You have to use an inverted bottle and all this stuff so it can't volatilize and you lose it. I don't have all the specifics, but the head of our groundwater section does, and he's gone this week. And I'll just say the same thing. If I don't know an answer, I'll always tell you to contact me and I will find an answer. But I can get that information to you. But you should start looking for labs that actually have radon testing as an option, and they should be able to provide you with all of the information on how to collect the sample and make sure you do it that way so that you're not, so it's done properly.
Steve, can I just chime in for a second and just say that I think radon in water is relatively uncommon. For what it's worth, I think most of the time it's in air. So when I was preparing for this, I looked up things about radon, and it seemed like radon in water was relatively uncommon because it tends to come out of the water as gas once it's
right. But so the EPA estimates that nearly 200 people die from radon in water a year. That's not very many. Like 130 of those are by breathing the volatilized radon, and the other 50 or 60 are because of stomach cancer. It's on the EPA's webpage. So, and it's not a very big risk. That's very few people in the course of, annually. But if someone's concerned about it, that's what EPA says. And if you just search for radon US EPA, it's an archive page, but they list all that information. Because if you go back through our webinars, I can't remember how long ago it has been since I answered that, but I provided all that data from their website. Okay, can scale buildup be removed from pipes? And the answer is yes. You can, one of the common ways, like especially if it's the drop pipe for a well, contractors can use acid and remove that scale. In your home, I'm sure that can be done as well. You'd have to talk to a contractor though. I've never really been involved in that. But yeah, there's a way to put water in there that will dissolve that. And I'm sure it's a specialized service. Not every contractor can do those things, but you just have to look for that. And as far as other approaches, I'm not sure. There's probably mechanical ways to do it as well, but it depends on the type of scale, how friable it is. You probably couldn't do that. With some things, you might be able to iron to use, some sort of spinning, something to break it up. But yeah, there are ways. How can the average well owner possibly afford testing when you have suspicions fear of organics and or inorganics, aquifers are constantly moving and constantly threatened by extraction or manufacturing activities, and periodic testing is unaffordable. Well, if there's a source nearby, then there's probably monitoring wells today to keep that on site or to know if it's moving. Any Superfund site, for instance, or anything like that, any company that's using chemicals that, yeah, I mean, you have to be close to a source is the bottom line for some of those things. And yes, an aquifer is always moving. The water in the ground is moving from a recharge area to a discharge area. But that doesn't, yeah. There just aren't huge plumes everywhere that are a threat. Now, if you have a source nearby and you know the groundwater flow directions in the direction towards your well, then yeah, I mean, it is expensive to test. But again, what it comes down to is by being a private well owner, you're taking on those responsibilities. You're in charge of paying for the sampling. You're in charge of replacing your well if it needs it, all those sorts of things. And I don't, I don't know of another approach other than if you know there's contamination and you might sample to prove it, it might cost you some money, but then you can go to your state or local agency. They will get involved. I know, like in Florida, there's been whole groups of homes that were on private wells where the state came in and put a rural water supply in free of charge. And then they went back after the company that caused the contamination. And it's, it's not a perfect approach, but yeah, it's part of, testing. Regular testing is really part of being a private well owner. So what method is used to test for PFAS in drinking water? So it's interesting because, as Evan mentioned, there are thousands of types of PFAS chemicals. The EPA has been working since all this blew up on methods for different ones. And the 7 he showed there, the 2 PFOA and PFOS that have a limit of 4, and then the others that are used, they actually do some math and put those 4 together as a number. And that number has to be below 1 total. Those have methods. There's many others that don't yet. And you'd have to check the EPA's website for the actual testing procedure that has been approved by EPA to determine those values and levels. Yeah, that's really in the weeds for any of us as far as, honestly, PFAS, we've just scratched the surface of all these PFAS chemicals. We're going to be working on this issue 10 years from now, just the same, and they're still going to be trying to determine methods and what the actual health effects are. That's why it's such a tricky problem, because even though they're all polyfluorinated, whatever the term was, many of them react differently, and many of them cause different kinds of health effects. So putting them all in one group is a problem from the start. And so, the best thing is to identify where those things are being used. And if you're close to one of those sources, to know which things to test for, if they have a methodology and they have a detection limit and all that stuff, because for a lot of them, there still isn't. So, but the best source of all that information would be the US EPA's webpage.
Yeah, Steve, I'll just chime in real quick because the next one is a similar line of questioning. Is that I'm looking at the EPA's methods right now, and there's several different methods, and our colleague John Scott also uses a different method than those. So if someone had questions about actual, like if someone was from a lab and had questions about those methods, they can contact me and I can point them towards John, who's kind of our PFAS expert around these parts. And I'd be happy to help them get some information if they were a lab person needing some info.
Okay. Yeah. I know boiling can raise nitrate nitrites, but can chlorine increase any of the common contaminants? I've not heard of that. I won't say that it can't because I don't know for sure, but I've not heard of it. And the biggest problem with chlorine is that, it can form disinfection byproducts, chlorine degradates, when it reacts with certain things in the water. And some of those are a known carcinogen. And so in some cases, communities have to switch from chlorine disinfection to chloramine disinfection because of that risk of causing those kind of problems. And I don't know, I've not heard of on a private well scale where there's not a lot of distribution, to through a community or whatever, of that being an issue. But that doesn't mean, it could mean that nobody's really looked at it. So continuous chlorination affects the metals in the submersible pump system. It can, but you shouldn't be chlorinating in your well. You chlorinate up after the water's been pumped up into your home. When I say continuous chlorination, that's not putting tablets in your well. Matter of fact, a number of states don't allow that anymore. And there's a great USGS study that shows when they started putting those tablets, there's a well in New Mexico, a bedrock well, or a series of bedrock wells that they sampled. It increased several metals like 1,000-fold because chlorine is an oxidant and it causes metals to be released. But when you chlorinate, what I'm talking about as far as chlorination would be like after your pressure tank, so that you're adding a feed, just like you put in a filter to stop something, or your softener, you have continuous chlorination with a liquid feed. So it shouldn't affect it would. It could affect not only your submersible pump and your drop line in your well, but it could affect, if you're putting it in the well, it could affect, if it's a bedrock well, any metals that are in the rock, and there usually are. Okay. I purchased a house recently with a private well. I had the well system and water tested. The results indicated no E. coli, but it did no total coliform was present. The tester mentioned that since the house was vacant for months, that the lines in the house just need to be flushed and it would resolve the issue. He mentioned that even if you were to not use the water for a few weeks, the total coliform results would indicate the same. Thoughts? Well, we kind of already answered that on an earlier question, but anytime you have coliform present, there could be some biofilms in some of the lines. There's growth there that harbors bacteria, or it could even be in the drop pipe or even in the well. You're not going to get rid of that without chlorinating. And so to say that it'll go away if you just flush it, it won't. Not necessarily, and there's no way to know that. Yeah, I would, anytime a home is sat, I would run a lot of water through all the lines, and then I would disinfect the whole thing. I'd shock chlorinate it. And we do provide on our website under lesson 10, the resources for lesson 10, a document from the Minnesota Department of Health, which I think is the best approach to shock chlorinating a well, because it has pictures and it walks through step by step and it provides the most detail on all that. So, but it's certainly worth doing. And the whole point is contact time. The water that has chlorine in it has to sit in your pipes long enough to kill whatever's in that section of pipe. And so it's all about having enough chlorine, leaving it sit overnight, all those sorts of things. Regarding PFAS, how many types of RO remove? Katie, is that the way this was typed?
That's how they wrote it.
Okay, so how many types can RO remove?
Probably.
Yeah, and we don't have enough information on this to really know. How many types can RO remove? I mean, there's, like I said, right now they're regulating 7, but there's, I know there's over 1,000 or whatever. So it's not a question we can answer. Many of them don't have detection limits or methods to detect them accurately at low levels, or do they know for sure what treatment is going to be best for those? And so really the thing to stick with is the 7 that the EPA has come out with for the regs for community water supplies, because those, they have methodologies and they know what can treat them and that sort of thing. Like I said, we're going to be dealing with this 10 years from now. It's just the way it is. We've used them since the 40s, as Evan mentioned, and it's not going to just, we're not going to just turn it off and get rid of them in a few years. It's just not going to happen. does the EPA have any regulations or I'm not sure what PROTIS is, specific for brain-eating amoeba? Well, that brain-eating amoeba is Naegleri fowleri, I think, fowleri. And it happens more often from swimming or those sorts of things. It's so rare that there aren't any regulations. I don't know. I know it's a real issue if somebody gets it. It happens usually in really warm climates, like in Louisiana, Mississippi, and some of those places. I don't think the EPA has any regulations. And I know there's no really effective treatment for it because if it gets in you, it happens too fast. And so I don't have any more information there. I know there's information on CDC's webpage about it, but yeah, I think it's a matter of maintaining chlorine residual and some of those things. Yeah, and I mean, I can look more up for you if you email me and ask. I would be glad to do that and talk to someone at EPA, but I don't have any other information there. So this is an interesting question. What could a detect of cis-1,2-diochloroethylene be an indication of? Well, that is a really specific question, and I feel like I'm being quizzed. But what I do know is that, because I looked it up while Evan was talking a minute ago, is that it's used in solvents and chemical mixtures. It's a combination of hydrogen and chlorine bonded to carbon. It does have, I believe it has it's classified as a probable human carcinogen. I don't have any idea of what it might be an indication of. If it's a solvent, it could be, if you're near a auto facility, a repair facility where they're using solvents to clean metal parts. I don't know enough about that, nor do we see it in private wells. So if you want to email me with a little more information about why you're asking, I probably can find some more information for you.
I did a quick search, Steve, and because I also
So
sounded like a red flag, and it seems like it could be like cleanup sites or something like that as well. So it's organic.
Yeah. Okay. In rural Western Massachusetts, I have a private new dug well. The water still smells like a swimming pool. Please advise. Is this the?
I believe that's the same question you already answered, Steve.
I do too. And metallic and smelling like a swimming pool are very different things. So again, the bottom line is you need to have a water sample done. And so you have some, we have some water quality parameters to look at and can make some decisions. Without it, we really can't advise on what to do until you have the sample results. And number 14, how much of a concern is radon in private well water? I think I mentioned that too. 200 cases a year is, very, very minor in the scheme of things. But if, you're concerned about it, or you have a radon remediation system in your home, and you want to test for radon, let us know. We can try to send you that information. Yeah, I think I've already answered that too. How can I check the depth of my well? I tried to contact the company that drilled my well, but they are no longer in business. Oh no. I also contacted my town to see if there were records, but there were none. So your town being the local health department, I guess is my question. It depends on what state you're in, but first thing to do is Google my state well logs, water well logs. Like if you do that for Missouri, you're going to get DNR. If you do that for Illinois, you're going to get the Water Survey, GeoSurvey, and Illinois Department of Health. If you do that for New York, you're going to get New York Department of Health or Minnesota Department of Health, because maybe they have some information. That's where I'd start. If you're in a town in the Northeast, where there's a lot of small towns that have private wells, like in New Hampshire. Then if your health district doesn't have it, then yeah, you're probably out of luck. But again, it'd be worth looking at other well logs nearby, and maybe they're all at the same depth, and there's only one real unit that everyone's using for their water supply, and then at least you know your well's probably close to that same depth. Yeah. And a lot of times when a company goes out of business, they give their well logs to another driller. So it might be worth calling some other drillers in the area and see if anyone knows if the company you used gave their records to somebody else. Because we've seen several cases of that in Illinois. One actually brought their records to us. So yeah. This is a question for you, Evan. On the ISWS website, it mentions an internal and external rate is internal or for any U of I employee. Also, would the determination of metals and trace elements only be 53 for one well? I'm reading the chart correctly, blah, blah, blah.
Sure. Internal means paying with University of Illinois account number. So if you're doing this for your private well, it would be an external sample. And yes, the cost would be per sample. So if you had one well but wanted to take 2 samples, that would be like a pre-post softener type of situation. That would be 2 samples, so the cost would be $53 for each sample. And the local address, I believe, is
2204 Griffith Drive.
2204 Griffith Drive. I guess I need to double check. I can update our website if it's not actually on there. But feel free to give me an email or to call the phone number or email us. Me or my colleague Monty will answer, and we can help answer the rest of your questions and get you set up with a kit. But yeah, Griffith Drive is here on campus on the University of Illinois in Champaign.
All right. Can we request living in a community paying for city water to have our water tested as a well? I mean, you're welcome to do that, but I don't know, you're not going to probably get the community to actually test your well, to test your water for you, unless you can show there's a problem, or, you know, unless they're just trying to be a good steward. And low pressure doesn't mean no pressure. If you ever have times where air pops out, and when you turn on your pump, or when you turn on your faucet, that's either an indication of some kind of gas or that the line wasn't full. In either case, then you should alert your community to that issue. But low pressure could mean a lot of things. It could be that there's a blockage in a line or other things. You should still let them know of those, but it doesn't necessarily mean that there's a water quality issue. We've certainly had cases where people that are on public water have sent a sample to us, or sent a sample in, or had a sample done and sent us the results so we could look at it. But you know, that's when that happens, you need to get your state primacy agency involved, because they're the one who regulate public water supplies. And if there's a problem with your water, they're the ones who have the authority to do something about it. So they're really, that's who you should contact.
Steve, I'll chime in a little bit. When I worked for a water department in New York anyway, if people had a complaint about their water, we would go out and we would take a sample and we'd test it, but we would only do a very limited test. So I think they might come out and do one for free, but you might not get the answers that you want. So
yeah, it really depends on whether they're trying to be a good steward or not.
Exactly.
Yeah. I've heard the recommendation of shocking the well, and the well owner pours a gallon of bleach down the well. Is there a specific recommendation on how to properly shock a well? So I'm going to go to our website, privatewellclass.org. Under resource library, there are class resources for each of the 10 lessons. Under water treatment solutions, there is a well and water system disinfection for private wells. April 2012, Minnesota Department of Health. This is what I recommend you follow. So pouring a gallon of bleach down your well or a cup of bleach down your well does nothing. When you disinfect a well, you mix it to the right concentration based on the diameter of your well and the amount of water in your well, which you can determine. There's a thing on here to help you determine that. As you go down this, there's a guide. Then you basically circulate the water. You put a hose in your well, go turn on the spigot, and you run it for a while. You're taking water out of your well and you're putting it back in your well, so that it effectively mixes the chlorinated water with all the well water. And then once that's done, you go in your house, you turn on every spigot or every faucet, every toilet, every shower until you smell chlorine, and then you shut them off and you leave them overnight. And by doing so, you put chlorinated water in all your pipes, because you're really not sure when you have a coliform problem where you need to shot chlorinate your well, where that problem is. It could be in the well, it could be in one of the lines, could be in the line going to your house, could be in a pipe that's close to your kitchen sink. But if there's any bacteria growing by chlorinating everything, it'll it needs contact time to actually kill it, and that's the whole point. So I recommend following that. It's if there's extenuating circumstances, if there's been a lot of biofilm buildup, the first time you shot chlorinate, it might only take off a layer and there's still more biofilm there. It's like the slimy stuff on the inside of a pipe. You might have to shot chlorinate it a couple times. We've seen that case. There's also an issue that chlorine isn't effective over a pH of 8. I don't have a great recommendation for that today, but if it is a high pH water, then chlorine's much less effective and it may not do the job. And so, those are just some of the things. But in a general sense, following Minnesota's recommendations is the best way to do things. So if I had a well and septic installed, should I ask the contractors for a completion report? Definitely. You should ask them for every piece of paper they have on both your well and your septic, so that you have all the information, any pictures they have, which companies made each of the pieces, all of that. You should know where your pump's set. You should know the material used for your well. If they pumped it to clean it out, what kind of drawdown there was in the well, what size pump they put in. I mean, just all of that stuff. And you should know the geology. And like I said earlier, if anyone who's going to put in a well, you make that part of your contract with them, that they're going to provide you all of that stuff. This is explained a little more in the class lessons in a little more detail. But yeah, that's where we're at. Well, hey, it's almost 3:30 Central Time, so we went a half hour over, and there's still 220 folks on here, which I really appreciate. I think we started out with close to 300. But for those of you that stuck around, I hope it was worthwhile. If you do have any other questions, here's our email address. Those go to Katie. She can send them to me that I need to deal with, or Evan needs to deal with. And again, we're in it to, if you've got a question that we couldn't answer, we'll find an answer. We know a lot of folks around the country who do this kind of work, and the folks at US EPA, and they've always been really supportive and helpful of our program, and they help us when we have questions. So thank you. Evan, when I turn this off, we'll lose you. Yeah, and again, thank you for attending.
Yes, thank you. And thanks for inviting me, Steve.